So what will be my x of n in this case? My x of n will be half of x1n that we have taken is e raised to j omega naught n, and x2n is e raised to minus j omega naught n. So in this case, my y of n will be equal to half. So I have to simply add y1 and y2. You can see a mod h of omega naught is a constant part, so I'll keep it outside. So let me write it first, a mod h of omega naught, and then I will write down the exponential terms which are different. So it's j omega n plus phi of omega naught, and obviously this j will be common to both the terms, because phase, when you write h of omega naught in polar form, the phase part will obviously be written with j. Similarly here also I'll keep this j outside because j will be common to both the terms. J will come here as well, so it will be minus j of minus omega naught n. So what I'm going to get here, this is my first term plus e raised to minus j omega naught n plus phi of omega naught. So this is what we get. So that's my overall y of n. Now this will bring us to some important conclusion. Look at the first expression for the input. Half e raised to j theta plus e raised to minus j theta is nothing but cos theta. So that's cos omega naught n. So the input signal that we have defined is a cosine function, and please do not forget that there was a along in the expression of x1 and x2, so that a remains outside. On this side, my overall y of n will become, I'll keep a as it is, I'll take mod h of omega naught, and you can see this half comes here, and this half along with exponential functions, you have again the same term, e raised to j theta plus e raised to minus j theta. So that will become cos of theta, but this time theta is omega naught n plus phi of omega naught. So this is a standard result that we were looking for. When the input to a system is a cosine function, which is a sinusoidal signal, the output is the same cosine function. You can see the frequency remains same, omega naught does not change. What is going to change is a gets multiplied by mod h of omega, and there was no phase angle was 0 in this signal, but you get new phase which is phi of omega naught. So that's the response to cosine function. Similarly, if I take x of n as a sine omega naught n, I can go through the similar derivation. My y of n will be nothing but a mod h of omega naught. Instead of cos, there will be sine here, omega naught n plus phi of omega naught. So this is what I'm going to get. So this is the response to sinusoidal signal. So we have got response to cosine as well as sine functions. In case of sine function also, you can see it's the same thing. Amplitude gets multiplied by mod h of omega naught, and the phase gets added, phi of omega naught, but the frequency omega naught does not change, and sine comes at the output in the sine form. So we will use these two important results and look at couple of numericals.